So we're asked to solve this set of nonlinear equations. Now, you could do this by substitution. That's what it looks like. When I first look at it, it says y equals. But if I do that, then if I plug it in the second one, I'm going to have to square all that. And I'm going to get like an x to the fourth, and that kind of scares me. So what if I make each of them look like x squared plus y squared or y, something like that. So if I take the first one, so I say y equals x squared plus 5, let's get all of our variables on one side. So let's subtract a minus x from both sides. So I get minus x squared plus y equals 5. Now I want to copy down the second equation. Ooh, check that out. Talk about luck. Okay, maybe not for me, but if it had been the first time I did it, I'd say it was luck. So the x squareds are actually going to cancel one another out. So I'm just left with y squared plus y equals 30. Now I want to set this equal to 0 so I can factor. So I'm going to subtract 30 from both sides. I'm going to write the answer at the top. So I'm going to get y squared plus y minus 30 equals 0. So I need to find out, are there any factors of 30 that have a difference of 1? Oh, I left out 5 times 6. So there we go, 5 and 6. So I've got a y and I've got a y. Remember I said the signs are different. The larger is positive, so I've got plus 6 and minus 5. So I'm going to set each one of these equal to 0 and solve. So y equals minus 6, y equals 5. So now what we need to do is we need to check and verify that these are solutions, and if they are solutions, what is their x counterpart? So I want you to do that, pause the video, come back and check your answer. So when I plug these back into the first equation, I got a negative number equals x squared. Well, we know that that's not a real number, that's an imaginary number, so there's no real solution. So we have just kicked out the y equals minus 6. Now on the other one I did get that x is 0, so that solution set's going to be 0, 5. So it's very important that you always check both y values.